Welcome to SYS Systems. My name's Rob Thompson, the sales manager here at SYS Systems. Today I'm joined by Matt Jones, a senior applications engineer from Stratasys. And in this video we're going to talk a little bit more about the PolyJet technology, which is a proprietary technology to Stratasys. So firstly, Matt, I don't know if you could give us a bit of an overview of PolyJet as a process, and we can talk a bit more then about the applications and some of the parts we've got.
Sure. So PolyJet's one of our core technologies. So I always refer to it as a glorified inkjet printer. So instead of using ink, we're using photopolymer resin, which we deposit down through the inkjet heads themselves, and we cure simultaneously with the UV light at the same time, which gives you the option to do multiple colours, whether it's transparent, opaque, different elastomerics, so different shore hardnesses or simulated shore hardnesses in one go. So it's basically a big printer, like an inkjet printer in your office.
Fantastic. So the process itself is well known within the R&D kind of market, and it's amazing how many different businesses are utilising PolyJet within their sort of prototyping and design development processes. Why would you say it's a technology of choice within those companies?
So it predominantly is used for prototyping or functional models and things like that. There are some end-use applications you can do, but it's the fit, the form, the look, the colours, the flexibility, the ease of use of the machine. It's really simple. You bring in your CAD, you process it in the GrabCAD software, you send it to your machine and you press print. It really is simple. Swapping out the cartridges, really easy to do as well. But again, it's like the FDM that I've previously discussed. You get a huge application diversity. So whether it's, there's a machine for dental, there's one for orthodontics, for medical applications, there's fabric printing as well, there's a research package which allows you to print on all different types of substrates and things as well. So it's a really diverse product to fit different industries, whether it's packaging, tooling, for universities, so studying medical applications or other things at schools and colleges. It's very good.
So diverse, isn't it, as a process? Let's just dwell on the prototyping and development side of things then a little bit first. So we can see a range of different parts in front of us here. One of the keys, I think, for the development market is people to reduce their time to market. Yep. And they want to have form, fit, function parts, of course, within their hands, so they don't have to commit to tooling. We know that. But ultimately, people wanting to now talk about getting a CMF, is that the right term?
Yep.
Model?
Yeah, so colour, material and the finish of a part. So if you're doing, for example, this speaker, you want to be able to have the colour of a fabric, for example, and also the texture. I know you might not pick it up on the camera, but the actual feel and the texture of a model, that's all done in the CAD. So whoever's designed this has spent a lot of time giving you the real finish of the fabric on side, along with matching the colours. So when you take a product and you give it out to your customer group, with a group that's going to be evaluating it before you actually manufacture it, it's very important that it is as close to the end use product as you can. And really, PolyJet's one of the only technologies out there that can do it, also with all the graphics for displays and things as well, that you're doing on there, and that can be swapped out all the time, all the way down to the PCB inside. Again, you can print it all as one, the speaker on the inside, the whole thing's modular. You can swap parts in and out. So for this example, it's a really good one for PolyJet because different covers, different displays, you've got one housing, main components, you've got all the soft buttons on the side, but you can swap components out so they can really evaluate the product, the shape, the fit, the form and feel before committing to tooling or just getting the end use prototype, that one that they really want to play with, made.
Superb. So I suppose one of the absolute benefits of this is people being able to get closer to that final part and not necessarily have to have sort of workshop capabilities necessarily within their office space. Tell us a bit more about the post-process then with PolyJet. The parts having to be post-cured, or is it just straight off the machine?
Yeah, so it's straight off the machine. You have a model material and a support material, and you need to remove or wash that away. You can do that either breaking it away by hand, using a water jet, or putting it in a tank to dissolve the supports completely. But it's a very easy way of doing it, and it's very quick. So if you've got a machine on the office floor where your design team are, you're going to take it off, you're going to take it and just wash away the parts, and then it's ready to go. You don't have to do UV post-processing. It's fully cured when it comes off, so it's safe to handle.
Yeah, so for those fast-paced design development teams where you've got a number of designers in there in the team and you're wanting to get through those iterations, this is an ideal technology for
exactly
that.
Like this one, for example, again, it's packaging, but being able to have the main shape of the cup or the holder, and then having different graphics on with different size fonts on the back of it, all sorts of things like that. To print those or to make them, it takes a lot of time to do in a traditional sense, but you can print multiples on a build, all in one go, all different colours, different shades, different transparencies, again, putting different textures on. So one build overnight, you can have 6 or 7, for example, and the next day be able to give that to the team to evaluate all the people that are going to hopefully say yes to your design.
I think that's one of the hidden benefits of PolyJet sometimes, is that all of these things can be printed on the tray at the same time.
Yes. Yeah.
People really do think about the overmolding capability here, which is obviously great. You can print more than one material or you can print multiple colours. But when you've got a design and development team that might be working on different projects, having the ability to have one printer take advantage of lots of different materials can get all of those done overnight or through the day for different teams, can't it?
Yeah, and it doesn't have to be full colour. I mean, we've got a lot of examples here that look very nice, but if you want monochrome, you've got the J35. You can do the greys, the blacks, the clears, the white materials as well. So if you don't need full colour and you still need like the Agilist materials to be able to give you that shore hardness, the different shore hardnesses, then it's ideal. You don't have to invest in a higher end machine if you don't need colour. A lot of R&D, product design, they just need black and white, to evaluate the fit, form and function of it.
Yeah, it really is a fantastic technology. And this technology really, outside of prototyping and development, there are other applications where we see people using it for production, believe it or not, and other industries where it's being utilised, predominantly in medical and dental as well, that we're seeing it being used. Do you want to just elaborate a bit more on that for us?
So orthodontics is a big one. We've got different machines to do different, basically to give you scale of production. So if you're not a massive house, you don't need lots and lots of them, then maybe one of the smaller machines is ideal. So for doing your vac form models over the top, the clear aligners, it makes perfect sense to use PolyJet for it. The materials are strong, robust enough to do so, gives you the right surface detail and accuracy, which is key for it. Or if you wanted to do full colour, you can do that as well, with different shades for the teeth, so A1, A2 and so on, all the way through to changing the gingival masks, different textures and feelings on that as well, to give you the realism of it. Copings, crowns, all sorts of things that you can do on the side of dental. For medical, again, study models is a good one. So if you're doing surgery planning, if there was a cancerous growth, for example, inside the upper mandible, you're able to print that off and evaluate that or give it to the doctors and the professors. So it's not just about printing parts, it's on this side of things, it's the patient recovery time, but it's also reducing the time that the patient's in surgery as well. So it's a big cost saving and time saving, but the key thing is the recovery time of the patient's massively improved by being able to prep properly and to see where the growth is or whatever it may be, and help to remove it. The materials we have on the sort of medical side of stuff, we're able to do bone, tissue, so again, depending whether you're an adolescent or a child, male, female, everybody has slightly different structures within inside the body, and you're able to simulate that as well. One of the key things that I always found a little bit freaky was being able to drill into a material that feels like you're drilling into bone. Not that I've ever drilled into real bones, but you're able to do that and simulate that. So for training, instead of using cadavers and things, 3D printing, PolyJet, it's a really good way.
Ideal. So yeah, whether that be actually in the hospital side of things, or actually within the development of these surgical tools as well, which
exactly,
is a big market for us as well. Yeah, it's really interesting how we're seeing that, and there's some big developments coming in the dental market as well, I think, isn't there? Probably into 2024.
Yep, so TrueDent is a material that's currently released in the US, so it's end-use parts that are directly going into the mouth. So for copings, crowns and things like that, it will be coming to Europe, hopefully fairly soon, but it's approved and it's in the dental market over there. So you can go to the website, you can see a load of stuff on that, again, A1, A2, A3, different shades, depending on how good or how bad your teeth are.
Yeah, amazing. So that's going to reduce a huge amount of workflow within these dental labs, having to actually place these teeth individually or actually manufacture them. So truly creating a digital denture within full colour is just going to be amazing.
It's the same for the orthodontic stuff. So being able to manipulate a tooth in CAD and twist it and move it around ever so slightly, and then to do the vacuum forming over the top for the split for the guards to go in. It's all a digital workflow. It's moved away from the old traditional ways, and obviously 3D printing PolyJet gives you the ability to take it to the next level.
That's a huge growth area for this particular technology. And more advancements that we've seen, I suppose, in the short term have been things like fabrics as well, which is, me and you can't say that we've been involved in the fashion world a lot in the last few years, but it's a market that's, again, picking up this technology and saying, what can we do with it? And we've now got a solution for that particular market.
Yeah, so we've got a couple of solutions. So you've got the fabric side of things, you've also got the research side of things as well. So being able to print onto fabric and also different substrates as well, but for fashion specifically, it's got to be like a porous fabric, so you're not going to print onto to leather and things like that. But the adhesion levels are phenomenal. So there are fashion houses out there now printing end-use garments that are safe to go into the washing machine. 600 cycles. They've got the UV testing to go with it as well. The colour testing and fading is all done. So you literally can print onto fabric and wear it as an everyday thing. So if you want to customise your outfits, find somebody with a printer and put your trousers, your shirt, your dress, your jacket and print on the top. The other thing is automotive, so being able to customise the interiors of cars. And there's use cases online from Mercedes and Peugeot where they are customising the interior dashboards of the car and the door sills as well. So it's going from what used to be prototyping to end use parts as well.
It's amazing how people pick the technology up and start to look where else they can use it, and a lot of the applications and material development is customer driven within the Stratasys
very much so,
technology, isn't it?
We wouldn't be where we are, to be honest, without the customers pushing the boundaries of what's possible. To print onto fabric or onto glass or onto wood or plastics. We as a company, the R&D development is a huge part of it, but just thinking, I'm going to stretch a piece of fabric and see if I can print on it, it's great.
And that's maybe where the research package is going to come into its own. So maybe a little bit more about how the research package works, but that's going to sort of almost open up that corridor to producing more out there parts utilising this technology, isn't it?
Yeah, so the research package basically allows you to print on what you want. You can change the start position of the platform, you can change the materials and all sorts of different things on there, but it gives you the freedom if you're trying to do something way out there that you can't do in a conventional way, and even there's restrictions within additive manufacturing and 3D printing. It gives you the ability in the GrabCAD software to mix different materials on the fly, print on different substrates.
Amazing. I'm sure there's going to be a lot more to come from PolyJet in the years to come. Materials and technology. So stick with us. If you've got any applications at the moment where you want to try out this technology, then please do get in touch.